Okay, so in this video, we're briefly going to discuss how to identify parabola, a parabola's function based on what we see on the graph. So first, let's look at an easy example, right? So let's just look at, I don't know, something like this. Okay, so let's say this happens at 7, right? And let's say, and you know what? That looks too well centered. Here, let's do this. I want it to be off-centered for a reason because I want our parabola to clearly not be symmetrical with the axis. Don't hate on my drawing skills. Okay, it's really early in the morning. Okay, so let's say y-intercept is at 7 and our vertex is at, let's say this is -3, and this right here, we'll call this +8. Okay, so our vertex is -3 by 8. Okay, so in standard form, so if we're in standard form, well, we can deduce that our c term here must be 7 because our y-intercept is 7. So we can at least figure that out. Okay, now if we are in vertex form instead, okay, we can tell two things. So we know our vertex, it's right here, -3 by 8, right? So that means ax, so -3, that means we would have to do +3 if we're going to shift to the left by 3. And then we went up by 8, so +8, right? So we get a lot more information for the standard form, right? But for both of these, we know a in this case, a in this case must be less than 0 because we're opening down. So that means a must be negative, right? So if we had like multiple choice or just had to guesstimate what, our function probably looked like, I mean, we get a pretty good idea just from looking at this picture and knowing what we know both about standard form and vertex form. Okay, so now let me throw a curveball at you. So you're not always going to have a function y as a function of x. You may have x as a function of y. Okay, and that can get a little bit crazy, right? It can get topsy turvy. Okay, so let's look at one of those. So let's say we had f of y now, right? F of y now is equal to, let's just look at the vertex form. Let's not worry too much about standard form just yet. Okay, so that would be a y minus h all squared plus k. Okay, so this is probably pretty difficult to think of in the standard orientation at first. So we're going to look over here in a non-standard orientation where basically our x and y flip their assignments. So x becomes vertical dimension, y becomes horizontal. Now our brains like seeing this. And of course, we're still positive going right, still positive going up. Okay, so let's see what we've got. So let's say we had a parabola that looked like this, right? And let's say our vertex was at, so now we got to remember our x and y's are flipped. So let's say y is -2 and x is negative, we'll say 6, right? So y is -6, x is -2. I'm still going to go ahead and put them in x, y, okay? And see, I'm already mixing myself up. This gets real confusing. Okay, so there we have it. So in vertex form, we know that that must mean we have y plus 2. Our h must be plus 2 because we went 2 to the left, right? And our k must be -6. Okay, and we see that a must be positive because we're opening upwards. Okay, so that's a few things we can deduce. But graphs don't look like this. They're going to have the x and y axis where they're supposed to be, right? So what does that mean for us? Well, we can easily transfer what we've done here over here to this other graph that's in standard orientation, right? And what we can go ahead and configure is that so x is -6, y is -2. Okay, so there's our vertex. Okay, and we're opening to the right, right? Because if we see here, right, if we turn this and lay it, if we rotate this 90 degrees, we see that we would be opening to the right where x gets positive. Okay, so this would be, and now here's the goofy part. So instead of saying f of y, we could say x equals some a that we still don't know, right? All we know is that a is greater than 0 because we're opening to the right, okay? Y plus 2 all squared minus 6, okay, because we have our vertex. Okay, so takeaways from this. You can easily tell what a function looks like based on how it opens up and where its vertex is and where y-intercepts exist. Okay, even if it's not a function of x and it's the other way around, x is as a function of y, just like what we see here. Okay, so that's all for this video. Let me know if you have any questions. Otherwise, goodbye.